Today's notes are over systems of linear inequalities. A system of linear inequalities is a set of two or more inequalities with two or more variables. So we're not just looking at one linear inequality today, we're going to be looking at two linear inequalities today. And solutions of systems of linear inequalities are any ordered pair, again that's x comma y, that satisfies both inequalities. So what does that mean? It makes both inequalities true. So just like we did in the linear inequality lesson where we plugged in the x and y value into one linear inequality and we said, is this a true statement or is this not? You have to plug that ordered pair into both linear inequalities. It has to satisfy both linear inequalities, meaning it has to be true for both of them. So let's look at this first example. We're just telling whether each ordered pair is a solution of the system of linear inequalities. So again, here's my x value and here's my y value, and I have to plug this into both of these linear inequalities. In this first one, I have x is greater than or equal to 5. So I know that's going to be like a vertical line, and I'm shading to the right, but all I'm going to do is plug in this x value. 6 is greater than or equal to 5. Is that a true statement? It sure is. Let's go to the next linear inequality. I'm plugging in -8 for y is less than -2/3. I'm plugging in 6 for x plus 2. And now I'm just going to simplify it. So -8 is less than, what's -2/3 times 6? It's -4. -4 plus 2 is -2. Is -8 less than -2? Yes, it is. So because this ordered pair satisfies both of these linear inequalities, I have two check marks here, right? It is a solution to the system of linear inequalities. Let's look at example number 2. In example number 2, I have 3 as an x value, 8 as a y value, and I'm going to plug this into both linear inequalities. So in this first one, 2 times 3 minus 8 is less than 4. So I just substituted 3 for x and 8 for y. And now I'm going to simplify it. 6 minus 8 is less than 4. What is 6 minus 8? It's -2. Is -2 less than 4? Yes, it is. Let's go on to the next one. Again, I'm plugging in 8 for y is less than -3 for x plus 3. And now I'm going to simplify it. 8 is less than -3 plus 3 is 0. 8 is less than 0. Is that a true statement? No, it is not. This ordered pair does not satisfy this linear inequality, and it has to satisfy both linear inequalities to be a solution. So it is not a solution to this system. Now, when we graph systems of linear inequalities, all we're going to be doing is graphing both linear inequalities on the same coordinate plane, like one on top of the other. And the solution set is the overlapping shaded region, the double shaded region. So what I would encourage you to do, and what a lot of students like to do, is maybe get out 2 different highlighters, 2 different colored pencils, 2 different colored pens, something like that, and you can graph one linear inequality in one color and the other linear inequality in another color. So I would pause the video and get out those resources if you have them. So our steps today are the same as they were with our previous lesson. We're going to convert each inequality to slope-intercept form. That looks like this. But again, we're not dealing with equal signs, we're dealing with inequality symbols. And we'll graph both lines on the same coordinate plane. The boundary lines and shading that we talked about in the previous lesson are still true for today because we're just graphing multiple linear inequalities. So let's look at this first example. Y is greater than 3x minus 1. I'm going to graph that. I'm going to graph -1 as my y-intercept, and my slope is 3. So from there, I'm going to go up 3 over 1. 3 over 1, and I can go down 3 over 1 this way. And then, is that line going to be dotted or solid? It's going to be dotted. And am I going to shade above or below? I'm going to shade above, so that's everywhere up here. Okay. Okay, so that's above the line. Now I'm going to get a different color, and I'm going to use yellow. I think that would be good. And I'm going to graph the second one. Y is less than or equal to negative 2x plus 4. On the same coordinate plane, I'm going to graph 4 as my y-intercept. My slope is negative 2, so down 2 over 1, down 2 over 1, down 2 over 1. Is the line solid or dotted? It is solid. And then do I shade above or below? Because it's less than or equal to, put your pencil on that line and go down. So when I go down, that looks like this. It's everywhere over here. So I've seen students who do different patterns whenever they're graphing. Like I did this kind of squiggly pattern in purple. I did these lines in yellow, but what you really want to see is the overlapping shaded region. And you can absolutely see that when you graph in two different colors. Any point that's in this overlapping shaded region, which is right over here, okay, all of this is the overlapping shaded region. If it's just in one shaded region, like up here, this point right here, down here, this point right here, those are not solutions to this linear inequality. It has to be in the overlapping shaded region, somewhere that I colored in brown. Now, what you have to remember is if it's on a dotted line, it is not a solution. If it's on a solid line, it is included in the solution set. So you really have to pay attention to the solid and dotted lines today. Let's move on. So for these examples, we're going to graph the system of linear inequalities on the coordinate plane provided and then determine if these ordered pairs given are solutions to the system, and then we'll circle yes or no. So in this example, y is greater than or equal to 1/2 x minus 5. So I'm going to graph my y-intercept of negative 5, and my slope is 1 over 2, 1/2. Up 1 over 2, and I'm just going to graph a whole bunch of points. Again, I really like, if I had a pencil and a paper right now, I would be putting a straight edge up to that. It would be a perfectly straight line. And so my symbol is greater than or equal to. Again, greater than is up here, less than is down here, and it's or equal to. So is it a solid line or dotted line? It is solid, so I'm just going to fill it in like that. And then I'm going to shade above, because everywhere above this line is in the solution set. It is a part of the solution for that linear inequality. But again, we're looking at multiple linear inequalities. So now let's graph the second one. Y is less than negative 4x plus 4. So the first thing I'm going to do is graph my y-intercept. And then I'm going to graph my slope of negative 4 over 1. So I'm going to go up 4 over 1, or I can go down 4 over 1, just like that. And then because it's less than, I know my line is going to be dotted. And if I'm going too fast, too slow, pause the video, fast forward, whatever you need to do. And again, that's a pretty steep line, so this is where students struggle. It's less than, so I shade below. Put your pencil on the line and go down. Everywhere below this line, down, is in the solution set, okay? So now can you see the overlapping shaded region? Which I wish I could highlight this a little bit better, but that's the best that I can do on this device. So the overlapping shaded region, that's my solution set. So let's go through these ordered pairs and determine if they are solutions. Negative 2, 1. So here's my origin right here. So negative 2, 1 is right there. Is that in the overlapping shaded region? It is, so it's a solution. 10, negative 3. Well, that's going to be over right 10. Down 3. Is that's not in any shaded region. So nope, that is not in the solution set. 3, 2. Start at my origin and go right 3 and up 2. Remember, it has to be in the overlapping shaded region. So that is not a solution. What about negative 2, negative 6? 4, 5, 6. That's right here. So it's in the shaded region for this peach color right here. And then that light blue inequality, linear inequality, is on the solid line. So it's a part of that linear inequality. It is a solution for that linear inequality. So does it satisfy both linear inequalities? It does. It's on a solid line. Let's look at 2, -4. 2, 1, 2, 3, 4, right there. Hold on a second. Over 2, and I'm going to go down 4. And that actually, you have a hard time seeing this, but I want to point something out here. It is on this solid line right here. Do you see it? That point right here? But what about this line right here? It's on this dotted line. That's actually the point of intersection of those two lines. But because one of them is dotted, it is not a solution. Okay, so if this other inequality right here were less than or equal to, that point right there would be a solution. But it's not because that one line is dotted. Okay, let's move on. Next example. So this is about as difficult as it gets because I have two linear inequalities here and I need to solve for y. So in that first one, x minus y is greater than 2. What's my first step? I'm going to subtract x from both sides. And I have this right here. And now I need to divide everything by -1. So I get y is less than positive 1x minus 2, because I divide everything by -1. So now let's graph that. I'm going to graph my y-intercept of -2, and my slope is positive 1. So I know it's going to look like this. And it's going to be a dashed line. How do I know that it, oh, that's kind of not a very good line. How do I know that it's going to be a dashed line? Because it's just a less than. It's not less than or equal to. But now do I shade above or below? I shade below. So I know it's everywhere. Down here is my shaded region for that linear inequality. Now let's go to our other one. I kind of like graphing them in maybe yellow, kind of that color. So now I've got 3x plus y is greater than or equal to 6. And I need to solve for y. Y is greater than or equal to -3x plus 6. And now let's graph this line. So I'm going to graph my y-intercept first. 1, 2, 3, 4, 5, 6. My slope is -3, so down 3 over 1. Down 3 over 1. Down 3 over 1. And is my line solid or dotted? It's or equal to, so it is solid. And then do I shade above or below? Above for greater than. Again, up here is greater than, down here is less than. Put your pencil on the line and go up. So everywhere up here is in the solution set for that linear inequality. Anything in the double shaded region on dotted lines, that is a solution for the system. So let's go through this. 2, 0. When I go to 2, 0, that's actually the point of intersection, but because one of those lines is a dotted line, is it a solution? No, it is not a solution. 5, 1, I'm going to go right 5, up 1. Is that in the double shaded region? Yes, it is. All this means is we're graphically determining this. All it means is that if I plug in 5 for x and 1 for y into both inequalities, I end up with a true statement, just like we did at the beginning of the lesson. So -3, 5. I'm going to go over 3, up 1, 2, 3, 4, 5. Absolutely not. 9, 7 over 9, up 1, 2, 3, 4, 5, 6, 7. Nope. That is on a dotted line, so that is not a solution. And then 4, -1. 1, 2, 3, 4, down 1. It's in the double shaded region, which you can see is in having purple and gold. So yes, that is a solution. And just keep in mind that on today's lesson, you'll also see problems that might have like x is greater than 2, y is less than or equal to 3, something like that, right? Well, all that means is you're graphing a vertical line for this linear inequality and a horizontal line for this linear inequality. And your rules from yesterday's lesson still hold true for today. You're just graphing both of these linear inequalities on the same coordinate plane. And your solution is the overlapping shaded region. So I hope these notes were helpful for you. Good luck.